click the bell icon to get latest videos from Ekeeda.
Hello guys, here we will start your mathematical analysis with numerical point of view for feedback amplifiers. And here we are coming with the first problem based on the negative feedback amplifiers. And let's start with the analysis and the mathematical aspect of the negative feedback amplifier with one particular exact numerical. Here on your screen, you have a circuit with three-stage amplifier. So we have learned multi-stage amplifiers. So if we have the gain related to each stage, so the product of each stage ka gain, that will be your total gain of your multi-stage amplifier. We'll use that concept somewhere to find out what will be your gain with feedback and without feedback. So hold on that particular part. Looking at this particular circuit, you will feel that this is very complex circuit. I will keep it as for option part, right? So, but don't do that. Only mathematical work, only few concepts are important. Only these three steps that we have learned in the previous videos, these are important for this particular problem solving. So, given part is given, that is IC1, IC2 and IC3. All the DC collector current values 0.6 milliampere, 1 milliampere and 4 milliampere which is given. HFE, that is nothing but the beta value for all the transistors is 100. RO, that is dynamic output resistance for each transistor is infinity, that is nothing but the open circuit. We don't have to consider that RO into this particular numerical, right? So that's the hidden part. We have to find out the gain with feedback, input resistance with feedback and the output resistance with feedback. So they have just specified that you have to find out the gain. They have not specified what is voltage gain, what will be your current gain, what will be your transconductance gain or transresistance gain. So your first step is to identify the feedback topology. Let's start with the step number 1. If you say, I have said you that how to find out the feedback topology is just by looking at the output side and the input side itself. If the feedback is taken from the output node or output terminal directly, then I can say that it's nothing but the voltage sampling. But if you're saying that this output voltage is isolated from this particular RF, right? Rather, it is not directly connected to your RF, right? So I can say that this is nothing but your current sampling. If it is not voltage sampling, then I can easily conclude that it's nothing but your current sampling, right? So here it is current sampling. Secondly, I can say that this RF is nothing but a feedback resistance. This feedback resistance is connected to the first stage of your multi-stage amplifier. That means it is trying to connect at the input side, but it is not directly connected to your base terminal. So it is not shunt mixing, right? Rather, it is not the shunt mixing, rather it is series mixing. So in short, I can say it's nothing but current sampling and series mixing. So we have got the feedback topology, right? So here we will say step number 1. Is mixed, right? So mixing, voltage is mixed. So, or I can say it's nothing but the series mixing, right? So conclusion is series mixing. And as current is sampled, not voltage, so it's nothing but the current sampling. So ultimate conclusion is feedback topology that I'm getting is nothing but current series negative feedback topology, right? So important part is it's nothing but current series negative feedback topology. So I can say that to find from here we will get to know that how we will be getting the value of ROF, how we will be getting the value of RIF and how we will be getting the value of AF, right? So here we will say that what is AF? AF is nothing but value of output parameter, that is IO, divided by the input parameter, that is voltage VS, right? So I want this particular ratio IO divided by VS in short. Clear? Then what we will calculate? We'll calculate A, that is nothing but IO divided by VI. Clear? Next is, we'll say what is RIF and what is ROF. Once we get the value of RI and RO, it will be very simple to find out what will be the value of RIF and ROF. As at the input side, this is the current sampling, right? As current sampling is related with the series connection, right? So as series connection at the output side, I can say that it's nothing but the 1 plus AB से multiplication. Series में resistance increase होता है, so I can say ROF is equal to RO into 1 plus AB. Similarly, at the input side as well, I can say it's nothing but the series connection. So again, I will be getting RI into 1 plus. So in short, we have got the input resistance, output resistance, and the gain with feedback. One particular parameter is left, that is nothing but B. What is B and how to find out the value of B? See to it that what is the value of B? B is nothing but the feedback factor for current series negative feedback. So whatever output parameter I am getting, that I will keep it at the denominator, because it is nothing but the input for feedback block, right? And what is the feedback parameter? That is nothing but the same as the input parameter, but with feedback VF, right? With the different value, parameter will be same. VF divided by IO is nothing but B. Now we have got that what exactly we have to find out. From here, step number 2 say we will start your exact numerical, right? So this is what we have to find out, right? In the step number 2, we have to draw particular circuit for without feedback and particular circuit to calculate the value of B as well. Okay, so step number 2, circuit without feedback. Okay, circuit without feedback अगर मुझे निकालना है, first of all we will draw the circuit for the B part. That means how to calculate that particular B. Here you can note that what is B? This is nothing but the feedback circuit. This completely gives you the idea regarding the feedback circuit. Okay, so I can say and this is the output parameter that we want, IO. Okay, and this is the input parameter that we have. We can say that this is your VF. Okay, so V what basically VF divided by IO. Okay, so what will be the value of VF divided by IO? We all know that if I am considering this IO, I will treat this as the source, right? You can say this is IO. This is your 100 ohm. I will write directly the value 100 ohm. This is 640 ohm, right? This is nothing but your RF. I will write these names as well. And this is your RE1. And this is also of value 100. Okay. So what we want? VF divided by IO. So before that, can we represent this in the form of source transformation? Yes, easily. So we can say that by using source transformation, we can do some changes in this particular circuit, as this will be as it is, this will be as it is, but along with that I can say this is a series connection and this is now your voltage source, right? So we can say this is your RE2 right? And this is your voltage source का नामकरण, that will be IO into RE2. Okay, so this is your RF and this is your RE1, this is your VF and this is your V, right? That is equal to IO into RE2. V is equal to IO into RE2. Very simple. Now we will use the what is, yes, voltage divider rule, right? So what we will write by using VDR, what do we get? VF is equal to RE1 divided by RE2 plus RE1 plus RF. So by VDR we will be getting VF is equal to RE1 divided by RE2 plus RE1 plus RF multiplied by the total voltage, that is nothing but V. So that V is nothing but, I will directly write down it as IO into RE2, right? So I will be getting the value of B now. We will be getting the value of B is equal to VF divided by IO, which is equal to RE2 into RE1 divided by RE2 plus RE1 plus RF, right? Now what we'll have to do? Put the value, get the answer, right? By just putting the value of RE2, RE1 and RF, we'll be getting the value of B, that is nothing but VF divided by IO, which is equal to 11.9, right? And as it is voltage by current ratio, I will put the unit as ohm, right? Keep this as equation number 1, right? Let's move to the circuit without feedback, right? So circuit without feedback, whenever I am calculating, we'll first have to understand this particular circuit and the feedback topology. If I'm saying the feedback topology is current series negative feedback topology, right? As this is the current, I will have to open this circuit, right? So to develop output circuit, as the connection is at the input side as well as output side is series, both sides will have to open the circuit. So what we'll have to do to develop output side, open circuit at input, right? If input is open circuited, that means VS, this is open circuited, don't connect this particular input side at the feedback side. So what we'll be getting, RF and this RE1, right, will be in series and this connection is in parallel with RE2, right? That will be your output side. So to develop output circuit, open circuit at the input and your new connection will become, this will be your resistance, that is 600 ohm, and I will just draw the output side. This will be your output side where RE2 and this is nothing but your series connection of RF and RE1. Okay, so this is to develop the output side. To develop at the input side, what we'll have to do? We'll have to open again at the output side. So to develop input circuit, open circuit at output. So if we say open circuit at the output, so don't connect that feedback to your main circuit at the output side. So we'll disconnect this particular emitter of the last transistor, right, from the feedback. So again I will be getting 640 and RE2 now in series, and that combination will be again in parallel with RE1. So I can say at the input side I will be getting, so far, this will be your Vs, and I can say at this particular emitter one resistance RE1 will be there, and the parallel combination I will be getting as RE2 and RF. You can draw RF above RE2 or RE2 above RF, that doesn't matter because it is a series connection. So we combine this particular part and we have to get the circuit without feedback. So I can say that circuit without feedback. So from that circuit we have to go for calculation. At the input side, I will be getting the connection with RE1, that is 100 ohm, along with the series connection of RE2 and RF. Okay, and then grounded. Now again here we'll be getting the same, that is nothing but RE2 connected with series combination of RE1 and RF. Very simple fundamental that we are understanding, that here I'm converting the with feedback circuit to without feedback. So whatever values I will be getting, I will just write down that particular values. So what we'll have to understand that now we will move towards the calculation part. To find out the value of A, whatever gain I will be getting as far as IO divided by VS part is considered, that will be nothing but your value of the gain without feedback. So now we'll start to find out what is the value of ratio IO. Rather, this is the IO I will be getting. IO, but as far as this IO and this IE3 is considered, that will be same because IC and IE will be same if I'm considering HF is equal to beta is equal to 100, right? So we'll say this is Q1, this is Q2 and this is Q3. So first of all, to find out the gain, that is nothing but IE3 divided by VS, what we'll have to calculate? We'll have to take the intermediate agent, right? So we will say that this is nothing but your VC1. This is nothing but your VC2, right? As we have taken that, this is the VS, this is no longer as the value of VI for without feedback circuit. So whatever value I am getting as VS, that will be treated as VI. Okay, so let's start with the value of VC1 with respect to VI, then VC2 with respect to VC1, and then what we'll have to do, we'll have to calculate the value of this VC2 with respect to IE3 with respect to this VC2, right? Then we'll get to know that what is the ratio of IE3 with respect to VI. Ultimately, it's nothing but IO divided by VI. Okay, so I will write it over here. A is nothing but, rather it is nothing but RM. RM is nothing but, it's not RM. A is equal to, it's nothing but GM is equal to the value IO divided by VI, which is equal to IE3 divided by VI. Now I will bifurcate this into few parts, that is IE3 divided by VC2 into VC2 divided by VC1 into VC1 divided by VI, right? Once we get all these three values, we have done with the A part, right? Let's calculate the value of VC1 with respect to VI, right? And that is nothing but the gain of the single stage amplifier. If we look at this particular gain of single stage amplifier, that if we form the AC equivalent circuit, then what we will be getting? That is nothing but the value of GM1 multiplied by this particular 9K, right? So what we will do, first of all, we have to calculate the intermediate parameter that are related to HFE, that are related to SE equivalent model, for example GM1, for example RPI, for example RE, right? So all these parameters that we have to find out. So let's start with the calculation of VC1 divided by VI. If we have this particular circuit, we'll get to know that the value of the voltage gain is reduced by this particular, due to this particular emitter resistance, right? So that emitter resistance as well we have to incorporate, right? In general, what we will be getting as far as the complete voltage gain for first stage is considered. So I will write the general statement for general formula for first stage voltage gain. VC1 divided by VI is being calculated as the RC minus, I will write minus RC divided by small re plus RE. Now for this particular circuit, what things we have to calculate, right? Now here we have to calculate all these three values, RE, capital RE and capital RC. Okay, RE is nothing but the value VT divided by IC. As far as this is the first stage, so I will treat this as RE1. I will have to take this as IC1. VT is a constant value that we take generally as 26 millivolts, and the IC1 value which is being given as 0.6 milliampere. Okay, so use this particular calculation, right? This will become 260 divided by 6. So here we will be getting 43 ohm in nearly for RE1. Okay, RE1 is done. What will have to calculate? The value of R pi, that is nothing but the input resistance for the second stage. So we will say R pi 2, which is equal to beta RE2, right? So as we have calculated the value of RE1, we again have to calculate the value of RE2 and RE3 as well. So RE2 is nothing but 26 millivolts divided by 1 milliampere, I guess, 1 milliampere, and that will come out to be 26 ohm. RE3 is equal to 26 millivolts divided by 4 milliampere, and that is coming out to be 6.5 ohm, right? So far we have got the values of RE2 and RE3 and RE1 as well. Fine. R pi 2 is nothing but beta into RE2. So we'll be getting beta is 100, right? So here we'll be getting 2.6 kilo ohm, right? What is the value of R pi 3? That is nothing but the value beta into RE3. That is nothing but 650 ohm. Okay, all values we have done. Now we will calculate what will be the value of RE, right? Capital RE is nothing but the calculation of RE1 in parallel with RE2 plus RF, right? Calculate this particular values, right? Then put this into this particular formula. RE1 will move with the value of RE1 we have calculated, that is 43.34. And what is the value of RC? We don't have to consider only 9K. Rather than that, we have to consider the input of the second stage as well, because this output of first stage is connected to the input of second stage. So here we have to consider the R pi 2 as well in parallel combination with 9K. So what we'll have to consider, this RC you have to calculate with the value RC1 in parallel with R pi 2, right? So this is also called as RC1 in parallel with beta RE2, right? Again, put this particular value in your RC Okay, I will just make a star so that you'll get to know that this value you have to incorporate, right? With this particular calculation, we'll come to the conclusion that what will be the value of VC1 divided by VI. Just do your mathematical calculation and come to the value. That value is coming out to be minus 14.92. I will treat this as equation number 2. One we already have considered as equation for feedback factor. Now first part is over. Second part is very important as far as the gain perspective is concerned. VC2 divided by VC1. Now again come to the without feedback circuit. Here it is VC2 and this is the value VC1. So very simple to understand that what will be the value of VC2 to VC1, as this is the no resistance at the emitter side of the second stage, then I can easily say that it's nothing but your value, that is nothing but the output resistance along with the load resistance in parallel combination divided by the respective RE value, that is RE2. Okay, I can say that this is nothing but minus RC divided by RE2. We all know that what's the value of RE2? RE2 is nothing but 26 ohm, right? So RE2, that we all know. What is the value of RC? So here we will write where what's the value of RC? RC is nothing but 5K. This is 5K in parallel with this combination along with this, right? So what we'll have to take? We have to take it as RC2 in parallel with the R pi 2 plus 1 plus HFE, that is nothing but 1 plus beta only, 1 plus HFE multiplied by this whole combination, that is nothing but RE2 in parallel with RE1 plus RF. A very huge circuit that we'll be getting, right? So that particular calculation you have to make. RC2, that is nothing but 5K in parallel with the R pi 2 plus 1 plus HFE. 1 plus HFE is, this is because we have to take this particular value at the base side. This complete resistance you have to shift at the base side, that's why we are taking this 1 plus HFE, right? This complete resistance that you have to shift at the base side, so we are considering 1 plus HFE. Okay, so calculate the value of RC. We all know that this is nothing but RC2 is 5K, right? R pi 2, that we have got it as 2.6 kilo ohm plus 101, right? RE2 is 100 ohm in parallel with RE1 also 100. RF is 640 ohm, right? Just calculate these values, check your calc is working or not, and then directly put this value in this particular formula. Whatever value that we'll be getting for VC2 divided by VC1, that is nothing but minus 131.2, and that we will treat it as equation number 3. Next we will move for the next part, that is nothing but your IE3 divided by VC2. Now here there is a confusion that all the values we have taken it as a voltage to voltage ratio. Now we have to consider it as the voltage current to voltage ratio. That is nothing but your the inverse of that of your the resistance part of input resistance of your the last stage. So consider the fact that we want to calculate the value of IE3 divided by VC2, right? As I know that what is the value of VC2? VC2 is nothing but VB3, right? So I can easily say that what will be that particular value. If I take this IE3 as HFE, nearly about HFE, it's actually 1 plus HFE, HFE into IB3 divided by VB3. I can say that this VB3 divided by IB3 is nothing but the input resistance, right? So it's a very simple thing that we have to analyze, that HFE divided by the RI3. Okay, now we should be very conscious to find out what is the value of RI3. I know that. What's the value of RI3? RI3 is nothing but the value which is related to the RPi3, value which is related to the RPi3 and this complete resistance. So if we look from this particular end after second stage into the third stage, we will get that particular value, and that particular value is nothing but RPi2 plus 1 plus HFE into RE2 in parallel with RE1 plus RF, right? That is nothing but your RI3. All the values are known to be, this is nothing but RPi3 rather than that of your RPi2, because we are considering the third stage. So RPi3 plus 1 plus HFE into RE2 in parallel with RE1 plus RF, that whole combination multiplied with 1 plus HFE, and then we have to take the series combination with RPi3, right? This is nothing but your RI3. You just put this value of RI3 into this particular formula, right? Here we'll get the value of HFE divided by RI3. HFE ka value is now known to us, that is nothing but 100. HFE is 100. So calculate the value of IE3 divided by VC2. According to my calculation, I have got IE3 divided by VC2, that is nothing but IO. According to my calculation, IE3 divided by VC2 is equal to IO divided by VC2, and that is equal to 10.6 milliampere per volts, because it is a current to voltage ratio. In earlier 2 or 3 equation, 2 or 3 formulas, we'll have not consider any unit because it's a voltage to voltage ratio. Here it is current to voltage ratio. I will treat this as equation number 4. Okay, so now we are on the verge to find out the value of the gain without feedback. So I can say that what is the value of A? That is nothing but Rm, and that is nothing but IO divided by Vi. This is equal to the Vc1 divided by Vi multiplied by Vc2 divided by Vc1. This is equal to multiplied by Ve3 divided by, or I can say IO divided by Vc2. From equation number 2, 3 and 4, we will be getting the value of Rm is equal to, first value that we have got as 14.92. Second value we have got it as, and third value is 10.6 milli. And that is nothing but, I can treat this as 10 to the power minus 3, right? Multiply these two and then we'll be getting the value of Rm, that is nothing but the value of gain without feedback. So we'll say that it's nothing but Rm is coming out to be 20.7 ampere per volts. Obviously don't forget to write these units because we have current to voltage ratio. We will treat this as equation number 5. Okay, now what we'll have to find out? We have to find out the value of gain with feedback. Okay, so for gain with feedback, we'll calculate first desensitivity factor. Okay, that is coming out to be 1 plus A into B, right? We know that what's the value of A, what's the value of B, calculate that particular value, and then we have to move further for AF, that is nothing but RMF, and that is nothing but the value of Rm divided by 1 plus Rm into B. Here A is nothing but Rm only for this particular topology. Okay, so Rm divided by 1 plus Rm into B, that we will be getting at 83.7 milliampere per volts. This is nothing but what we require actually for your gain with feedback. This is the first finding that we reach. We will move towards the second finding, that is nothing but your input impedance. Now things will become very simple. Once we get the value of Ri, what is the value of Ri? As far as Ri is considered, Ri calculated by using this particular without feedback circuit. So from without feedback circuit, we'll be easily get that this is nothing but R pi 1, and that is nothing but in series with this particular emitter resistance that we have to shift it towards the base side, because input is being calculated at the with the base current. Okay, so what we will do, we will say this is nothing but R pi 1 plus 1 plus HFE multiplied by RE1 in parallel with RE2 plus RF. This is how we will be getting the value of Ri. Okay, and that Ri is coming out to be 13.11 kilo ohm. Okay, you can check your calci whether it is working or not. Pause your screen and then again come to me. Once we get the value of Ri, we can easily get what is the value of Rif. Rif is nothing but Ri into 1 plus Rm into B, or you can also say it as Ri into 1 plus AB, because we have treated A and Rm as equal value. Value is coming out to be with the RMB plus 1 multiplied with by Ri, or we can take this particular formula, one of the same thing. The value is coming out to be 3.24 mega ohm. 3.24 mega ohm. This is the value of Ri. Value of output impedance that we will be getting as Ro. Let's move towards the output side. What's the value of Ro that you have to find out first? That Ro you have to get it from the input side of this particular emitter side of this particular third stage of an amplifier. So here I will be getting it as Re1 plus Rf in parallel with Re2. This is nothing but the emitter side. Now what we'll have to do, we have to shift this complete resistance which is placed at the base side. That is nothing but the R pi 3 along with this 5K. So what we will do? We will do R pi 3 plus the value of RC2 divided by 1 plus HF. Right? Because now we are moving this resistance R pi 2 and RC2 at the emitter side. So that's why we have to divide this by 1 plus HFE. So this is the value of RO you will be getting. Put the value of RE1, RE2, RF, R pi 3, RC2, whatever value it is given on in the numerical. And that RO is coming out to be 143.9 ohm. Right? Now, we don't want RO, we want ROF. We don't want RO, we want ROF. So ROF is nothing but RO multiplied by 1 plus AB, or we can also say it as RO multiplied by 1 plus RM into B. B value we have already calculated, RM we have already calculated, RO we just have found out, and then with the use of calci we'll get this value ROF as 35.6 kilo ohm. Okay, so far whatever values we have got, this is the third value expected, this is the second value expected, and this is the first value expected. We have calculated all the three values. We will write it in an answer form. So answer is AF is equal to RMF is equal to IO divided by Vs, which is equal to 83.9 milliampere per volt. Don't forget to write the unit because it's not the voltage by voltage or current by current ratio. Again, moving towards the RIF, right? That is coming out to be 3.24 mega ohm, which is very high. Similarly, at the output side, ROF, which is coming out to be 35.6 kilo ohm. So these are our calculations that we have done for the given negative feedback amplifier. This negative feedback amplifier numerical is bit complicated in this particular numerical. In the next video, we will learn some different aspect of the negative feedback amplifier numerical. So stay tuned for that. Learn more and more EDC along with me, along with Ekeeda videos. Subscribe this particular channel. Thank you so much.